Good morning. Today we will discuss about the skin as per your syllabus. The syllabus for BMS first year expected by Central Council of Indian Medicine is function of skin, sweat glands and sebaceous glands. But other parts are also important and we are going to see the all parts of the skin. Introduction. The skin is important body organ which contribute in the homeostasis by protection of the body, regulating body temperature and allows different sensations. Skin also reflect our emotions and is also visible structure for which persons spend much time and money to maintain it because everybody feels that our skin should looks beautiful. Skin and its accessory structures, hair and nails, glands contribute homeostasis. Skin can be inspected easily and it has the highest exposure to infection, disease, injury and also to the trauma, sunlight, microbes and pollutants. It is also a part of non-specific resistance of the body because it is first line of defense to fight against these foreign bodies. One more thing, the skin color also gives clues to about the diagnosis. Bluish color called cyanosis indicates hypoxia, that means low oxygen level. The pallor indicates anemia, means low amount of the hemoglobin and RBC and low oxygen carrying capacity of the blood. Abnormal skin eruptions like rashes, warts, age spots, pimples, abrasion, blisters, callus, papules indicate different skin diseases. After inspection of these things, you can conclude to the different kind of a diagnosis. What is dermatology? Dermatology is a medical specialty that deals with the diagnosis and treatment of the disease. Now let us see structure of the skin. We have to see the functions of the skin, but function cannot be learned without structure. The skin is the largest organ of the body in surface area and weight. Skin covers area of 2 square meters or 22 square feet and its weight is 4.5 to 5 kilograms, about 16% of your body weight. Thickness of the skin varies from 0.5 millimeter, which is at eyelid, to the 4 millimeters, which is at heels. Now, principal parts of the skin are epidermis and dermis. Epidermis is superficial layer and dermis is a deep layer. Epidermis is made up of epithelial tissue and dermis is made up of the connective tissue. The subcutaneous layer is deep to the dermis, but it is a not part of the skin, which is also known as hypodermis. Actually, it is not a part of the skin, but it has many functions in relation with skin. Now, this epidermis of skin contains 4 types of cells: keratinocytes, melanocytes, Langerhans cells and Merck cells. You can see here 4 types of cells. First first keratinocyte, then melanocyte, then Langerhans cells and last one is Merkel cells. These 4 types of cells are present in the skin. First, keratinocyte. About 90% of the cells of the epidermis are keratinocytes, which produce protein keratin. Keratin is tough fibrous protein that protect the skin and underlying tissues from the heat, microbes and chemicals. Keratinocytes produce lamellar granules which release water repellent sealant that decrease water entry and loss and inhibit the entry of foreign particles through the skin. Second type of cell is melanocyte. About 8% of the cells of the epidermis are melanocyte, which produce the pigment melanin. Melanin contribute to the skin color and absorb damaging ultraviolet light. Though they protect other cells from the ultraviolet light in the sunlight, they themselves are susceptible to the damage from ultraviolet light. This ultraviolet light is present in sunlight. Langerhans cells participate in the immune response against microbes but can easily damage by the ultraviolet light. Merkel cells help in detecting the different aspect of the touch and sensations. So these Langerhans cells and Merkel cells, as you remember, we have seen in the immune system also, they are also part of the immune system. Peacefully you can see this structure consists of the different parts of the skin, epidermis, dermis, hypodermis, different layers. Now epidermis of the skin has 5 layers. Stratum corneum is outermost layer. From outermost to the deepest layer, second one is stratum lucidium, stratum granulosum, stratum spinosum, stratum basale. Now, two types of skin are there, thin skin and thick skin. Thin skin has 4 layers except stratum lucidium, and thick skin contains additional stratum lucidium as a 5th layer. That is different between thick and thin skin, about which we are going to learn. Now here in this figure, the different 5 layers of the epidermis are shown. Now stratum corneum. Stratum corneum consists of 25 to 30 layers of the dead keratinocytes. These cells are continually shed and replaced by the cells from deeper strata. Its multiple dead cell layer protect deeper layers from the injury and microbial invasion. Constant exposure of skin to friction stimulate the formation of callus, which is present on the skin, and abnormal thickening of stratum corneum. This is outermost layer. Now stratum lucidium is present only in the thick skin of the finger strips, palms and soles. It consists of 4 to 5 layers of keratinocytes and contains large amount of the keratin. We have seen the functions of the keratin, how the keratin is important. Now this stratum granulosum is the 3rd layer of skin and has 3 to 5 layers of the keratinocytes that are undergoing apoptosis. Then what is apoptosis? Apoptosis is an orderly genetically programmed cell death in which the cell die. This layer contains protein keratinohyaline which convert tonofilament into keratin and lamellar granules which release a lipid-rich water-repellent secretion. These tonofilament, when attached with the desmosomes, they produce or develop the cell's keratinocytes. Stratum spinosum contains 8 to 10 layers of the keratinocyte. Spiny projections in a prepared tissue section is a point where the bundle of tonofilaments are increasing in desmosomes, tightly joining the cells to one another. This arrangement provides both strength and flexibility to skin. Projections of Langerhans cells and melanocytes also appear here. Now last, stratum basale. Stratum basale is the deepest layer of the epidermis composed of the single layer of the keratinocyte. Cells in this layer have the stem cells which undergo cell division to produce new keratinocytes. Keratinocyte in this layer has large nucleus and cytoplasm with many ribosomes. The cytoskeleton in keratinocyte include filament called tonofilament which form keratin in superficial layers. Stratum basale is also known as stratum germinativum to indicate its role in forming new cells. Now, there is an important procedure takes place in the epidermis, that is keratinization. At the same time, growth of the epidermis of the skin. Newly formed cells in the stratum basale are slowly pushed toward the surface. They are pushed toward the stratum corneum. That means they cross 5 layers. As the cells move from the one layer to the next, they accumulate more and more keratin, a process called as keratinization. Then they undergo apoptosis. Then keratinized cells slough off and replaced by the underlying cells that become keratinized. This process of keratinization from basal to corneum takes about 4 weeks in 0.1 millimeter of the skin. Here, hormone epidermal growth factor play a role. Now, dermis of the skin, it consists of two regions, papillary region and reticular region. Let us first see the dermis. The second deeper part of the skin, the dermis, is composed of strong, dense, irregular connective tissue containing collagen and elastic fibers. It is much thicker than the epidermis, and this thickness varies from the region to the region in the body, reaching its greatest thickness on the palms and soles. Because the dermis is typically thinner in women than in men, many women have appearance of the dimples in the skin, referred to as cellulite. Now, dermis has great tensile strength, resistance to pulling or stretching forces. It also has ability to stretch and recoil easily. As is typical of all general connective tissues, the cell present in the dermis includes fixed cells and wandering cells. The predominant fixed cells are fibroblasts, and wandering cells includes macrophages, mast cells, eosinophils, neutrophils, dermal interstitial dendritic cells. Blood vessels and nerves, along with the glands and hair follicles, are embedded in the dermal layer. Based on its tissue structure, the dermis can be divided by an indistinct boundary into thin superficial papillary region and a thick deeper reticular region. The papillary region of the dermis. The papillary region makes up about 1/5 of the thickness of the total layer. It consists of thin collagen fibers and fine elastic fibers. Its surface area is greatly increased by small finger-like structure that project into the undersurface of the epidermis called dermal papilla. These greatly increase the surface contact between the papillary region and the dermis. The dermal papilla can vary greatly in size and number throughout the different parts of the dermis. They are taller and more numerous in the sensitive region of the skin that experience more mechanical stress. In the thin skin, covering most of the body is dermal papillae are relatively few in number and small and irregularly scattered. By contrast, in the thick skin of the palmar surface of the hands and plantar surface of the feet, the papillae are relatively numerous, tall, and arranged in the patterned rows. All dermal papillae contains capillary loops, that is blood capillaries. Some contains encapsulated touch receptors called corpuscles of touch or Meissner's corpuscles. As their name implies, corpuscles of touch are sensitive nerve endings that detect touch. Still other dermal papillae contain free nerve endings, dendrites that lack any apparent structure specialization. Different free nerve endings initiate signals that produce sensation of warmth, coolness, pain and tickling and itching. Now, reticular region of the dermis. The reticular region, which is attached to the subcutaneous layer, consists of bundle of thick collagen fiber and scattered fibroblasts and various wandering cells such as the macrophages and some coarse elastic fibers. In addition, some adipose cells can be present in the deepest part of the layer. The collagen fiber in the reticular region are arranged in a net-like manner and more regular formation than those in the papillary region. The more regular orientation of the large collagen fibers aligns with the local tensile forces to help the skin resist stretching. Blood vessels, nerves, hair follicles, sebaceous glands, sudoriferous glands occupy the space between the fibers. Now, type of skin. Although the skin the entire body is similar in structure, there are quite a few local variations related to the thickness of the epidermis, strength, flexibility, degree of keratinization, distribution and type of hair, density and type of glands, pigmentation, vascularity means blood supply, and innervations, mean nerve supply. Two major types of skin are recognized on the basis of certain structural and functional properties: thin or hairy skin and thick or hairless skin. Now let us focus most important part according to us, that is functions of skin. Following are the skin functions in the human body. Number 1, thermoregulation. Number 2, protection. Number 3, sensation. Number 4, excretion. Number 5, absorption. And number 6, synthesis of vitamin D. Now thermoregulation. The skin contributes to thermoregulation by regulating body temperature in two ways, that is thermolysis and thermogenesis. Now, by liberating sweat at surface and by adjusting the flow of blood in the dermis. In response to high temperature in environment, temperature or heat produced by exercise, sweat production increases. The evaporation of the sweat from the skin surface helps lowers body temperature. In addition, blood vessels in dermis dilates, which increases amount of heat loss from the body. But when in response to low temperature in the environment, production of sweat decreases, which help to conserve heat. Also, blood vessels in dermis constrict, which decreases blood flow and reduces heat loss from the body. Second function is protection. The skin provides protection to the body in various ways. Keratin protects underlying tissues from the microbes, abrasions, heat and chemicals. The tightly interlocked keratinocyte resists invasion of the microbes. Lipid released by the lamellar granules retard evaporation of water from skin surface, thus guarding our body against dehydration. They also retard entry of the water across the skin surface during showers and swimming. The oily sebum from the sebaceous gland helps skin and hairs from drying out and contains bactericidal chemicals that kill the surface bacteria. The acidic pH of the perspiration retards the growth of some bacteria. The pigment melanin helps shield against the damaging effect of the ultraviolet light. Two types of cells carry out protective functions that are immunological in nature: epidermal Langerhans cells and Merkel cells. Epidermal Langerhans cells alert the immune system to presence of potentially harmful microbes invaders by recognizing and processing them, and macrophages in the dermis phagocytes bacteria and viruses that manage to bypass the Langerhans cells of the epidermis. Merkel cells have the same action. Sensation is the next function. Cutaneous sensations are sensations that arise in the skin, including tactile sensations such as the touch, pressure, vibration, and tickling, as well as thermal sensations such as warmth and coolness. Another cutaneous sensation is pain, usually an indication of impending or actual tissue damage. There is wide variety of the nerve ending and receptor distributed throughout the skin, including tactile disc of the epidermis, the corpuscles of touch in the dermis, and hair root plexus around each hair follicle. The next function is excretion. The skin normally has small role in excretion, elimination of the substances from the body, and absorption, the passage of material from the external environment from the body cells. Despite almost waterproof nature of the stratum corneum, about 400 ml of the water evaporate daily. A sedentary person loses additional 200 ml per day as a sweat, that means total 600. Physically active person loses much more. Besides removing water and heat from the body, sweat also is the vehicle for excretion of small amount of salt, carbon dioxide, oxygen, and two organic molecules that result from the breakdown of the proteins, that is ammonia and urea. Absorption. The absorption of water-soluble substances through the skin is negligible, but certain lipid-soluble material do penetrate the skin. This includes fat-soluble vitamin, that is ADAK, and certain drugs and gases O2 and CO2. Toxic material that can be absorbed through the skin includes organic solvents such as the acetone and carbon tetrachloride, salts of heavy metals such as the lead, mercury, arsenic, and other substances in poison. Absorption. Since topical steroids, topicals means applied to the skin, such as cortisol, are lipid soluble, they move easily into the papillary region of the dermis. Here they exert their anti-inflammatory property by inhibiting histamine producing by mast cells. Now, synthesis of vitamin D. Synthesis of vitamin D required activation of the precursor molecules in the skin by ultraviolet rays in sunlight. Then only these vitamin D synthesis is possible. Enzyme in liver and kidney then modify the activated molecules, finally producing calcitriol, the most active form of vitamin D. Calcitriol is a hormone that aids the absorption of calcium in the food from GI tract. It takes it toward the blood. Now let us see the skin glands. Glands are the single or group of epithelial cells that secrete substances. Several kinds of the exocrine glands are associated with the skin: sebaceous glands, odoriferous glands, ceruminous glands, and mammary glands. But mammary glands, which are specialized odoriferous glands that secrete milk and are the part of female reproductive system. Now sebaceous glands. Sebaceous glands or oily glands are simple branch acinar glands. With few exceptions, they are connected to hair follicles. The secreting portion of sebaceous glands lies in the dermis and usually opens into the neck of the hair follicle. In other locations such as the leaves, glans penis, labia minora, sebaceous glands open directly onto the surface of the skin. Sebaceous glands are absent on palms and soles. Sebaceous glands secrete an oily secretion called sebum, which is a mixture of fats, cholesterol, protein, and inorganic salt. Sebum coat the surface of hairs and help keep them from drying and becoming brittle. Sebum also prevent excessive evaporation of water from the skin, keep the skin soft and pliable, and inhibit the growth of certain bacteria. Sebaceous glands, which vary in size and shape, are found in the skin over all regions of the body except the palms and soles. Because of their relationship to hair, sebaceous glands are most numerous where hairs are most present. They are small in most areas of the trunk, limbs, but large in skin of breast, face, neck, and upper chest. Now, sudoriferous glands, another type of gland. There are 3 to 4 million sweat glands or sudoriferous glands in the body. Sudoriferous glands are also known as sweat glands. The cells of the sweat gland release their secretion by exocytosis and empty them onto the skin surface through the pores and into hair follicles. Depending on their structure and type of secretion and location, the glands are classified as ecrine or apocrine. There are 2 types of glands. Now, ecrine glands, also known as merocrine sweat glands, are simple coiled tubular glands that are much more common than apocrine sweat glands. They are distributed throughout the skin of the most parts of the body, especially in the skin of the forehead, palms, and soles. These glands are absent at the margin of the lips, nails, buds of the fingers, toes, glans penis, glans clitoris, labia minora, and eardrum. The secretory portion of the ecrine sweat gland is located mostly in the deep dermis. The excretory duct projects through the dermis and epidermis and ends as a pore at the surface of the epidermis. On the palms and soles, they open all along the apex of the epidermal ridges. The sweat produced by the ecrine sweat glands, about 600 ml per day, consists of water, ions, mostly sodium and chloride, urea, uric acid, ammonia, amino acids, glucose, and lactic acid. The main function of ecrine sweat gland is to help regulate body temperature through evaporation. As sweat evaporates, large quantity of heat energy leaves the body surface. The homeostatic regulation of the body temperature is known as thermoregulation. The role of ecrine sweat gland in helping the body to achieve thermoregulation is known as thermoregulatory sweating. During thermoregulatory sweating, sweat first forms on the forehead and scalp, then extends to the rest of the body, forming last on the palms and soles. Sweat that evaporates from the skin before it is perceived as a moisture is termed a sensible perspiration. Sweat that is excreted in large amount and is seen as a moisture on the skin is called sensible perspiration. Now, sweat produced by eccrine sweat glands also play a small role in eliminating waste such as the urea, uric acid, and ammonia. Now, these eccrine sweat glands also release sweat in response to emotional stress such as the fear and embarrassment. This type of sweating is referred to as the emotional sweating or cold sweat. In contrast to thermoregulatory sweating, emotional sweating first occurs on the palms, soles, and axillae and then spread to other areas of the body. Now, another type of sweat gland called apocrine sweat glands are also active during emotional sweating. Apocrine sweat glands, like eccrine sweat glands, are simple coiled tubular glands. They are found mainly in the skin of axilla, that is armpit, groin, areola, pigmented areas around the nipples of the breast, and bearded regions of the face in adult males. Now, secretion of apocrine is released by exocytosis. The secretory portion of this sweat gland is located mostly in the sebaceous subcutaneous layer and the excretory duct open into the hair follicles. The secretory portion of apocrine gland has a simple cuboidal lining of the secretory cells whose free surfaces project into the lumen of the gland. Now, this secretory product is slightly viscous compared to the eccrine secretions and contains same component as eccrine sweat, plus it has got the lipids and proteins. At first, this substance is odorless, but as it spread onto the hairs, bacteria decompose the proteins, creating a strong musky odor that is called body odor. In women, cells of apocrine sweat gland enlarge at about the time of ovulation and shrink during menstruation. Eccrine sweat glands start to function soon after the birth, but apocrine sweat glands do not begin to function until puberty. The secretory product of apocrine gland is slightly viscous compared to we have seen. Apocrine sweat glands are stimulated during the emotional state and sexual excitement. These secretions are commonly known as cold sweat. In contrast to eccrine sweat gland, apocrine sweat glands are not active during thermoregulatory sweating. Now, third type of gland is ceruminous glands. These are the modified sweated glands in the external ear called ceruminous glands, produce a yellowish waxy lubricating secretion called cerumen, in which the sebum is also mixed. Excretory portion of the ceruminous gland duct opens either directly onto the surface of external auditory canal, which is present in the both of the ears. Now, combined secretion of the ceruminous and sebaceous gland is called cerumen or earwax. Cerumen in the external auditory canal provide a sticky barrier that prevent the entrance of the foreign bodies such as the insects in the ear. Cerumen also waterproof the canal and keeps bacteria and fungi from entering the cells. Now, what is wax? Some people produce an abnormally large amount of the cerumen in the external auditory canal. If it accumulates until it becomes impacted, firmly wedged, sound waves may be prevented from reaching the eardrum, and that will cause a deafness to that person. Treatment for impacted cerumen includes periodic ear irrigation with enzymes to dissolve the wax and removal of the wax with blunt instrument by trained medical personnel. Then this treatment is possible. So friends, today we have seen about the skin. You should remember two layers of the skin, epidermis and dermis. In epidermis, 5 layers, and in dermis, 2 parts. Then you should not forget 6 different functions of the skin. Then 3 types of glands, so far we have seen. It is also important 4 types of the cells present in the epidermis. When you will learn and understand all these things, you will be able to understand the skin diseases, which are very important. So, thank you. Have a good day. Thank you very much.